Yay! So today we will talk about the ontologies, graph databases, and actually the engineering practices and development. Because uh, when you try to bring the graphs to the engineering teams, usually you need to explain a lot of things, how the things is working, and uh, they needs to join the two different worlds because from one side you have probably the RDF store and ontologies and something that focus on the triples, and or maybe you working on the labeled property graphs, and then it's mean that you focus more on more object like things, but still even the labeled property graph with the properties in a node have ability to model way more richer relations and the shapes uh, than regular relational databases, and it could create the challenges for the understanding by the engineering teams, because how the regular engineering teams that work with the relational databases operate usually that they have the ORM, object relational mapper, that able to map somehow relational tables to the data transfer objects, and the nature of the relational databases that they have the fixed columns and they have the fixed foreign keys. It's more suitable for this process because somehow the data shape is, it's graved in stone, and it's not so flexible, but it's not the use case for the graphs because yeah, for sure you have the properties, and we already talked that, for example, we could benefit from the shapes of the properties of that model it with frames and frame-based ontologies that make the ontologies closer to the this object-oriented thinking and object-oriented approach. But still, your graph is way more flexible. It's the challenge that it could be too flexible. Yeah, because in a graphs, uh, you could easily describe the ontology that could have the wide variety of shapes. And it's mean that to reflect uh, the same subgraph that represent, for example, the complex event, you could have the variety of invariants and multiple types. And it's the question how we map the subgraphs with the complex relations to the data type. And I found actually a couple of projects that actually do this graph to object mapping. So we have something similar that we have in a relational databases with the relational object mapping, but the graph object mapping actually it's the process where you take the graph oriented data and map them to uh, some complex domain driven object. And in terms of mapping the nodes, it's straightforward because actually you have the shape of the properties that just could be reflected in a shape of the object, and somehow you are done. But what we could do with the relations, because you could have the multiple relations to the different objects, and then you need to have some more complex representation that shape these objects. And in case when you have limited ontology of possible relations, then you could, sketch some fixed subgraphs. So, and for example, if we describe in the event, we could say that event also have the actor's location and maybe some time components. But in some different cases, the event, for example, could have some temporal relations with other events, and it's completely different types. And it's the problem that direct mapping of the graph to the object, it's not so straightforward task, and that's why the graph to object mapping probably could not be made automatically, and it's really depend on your use cases. But what actually we could do with it? So I have seen couple of interesting projects for the new Neo4j that actually bring um, the property graphs to object mapping. I also have seen a couple of projects for Java that try to work with the graph-oriented databases as this Spring data objects, and they all quite interesting and good. Maybe it's not fitting our needs because I work more with the TypeScript, and we don't really have the full scale graph database, because we model our graph in the relational model. From one side, it's make the task easier because then you have the relational databases. But from another side, you still model the complex the graph structure in the relational world. So you couldn't just go to the database and map the tables, because then you will lose the semantics, right? And yet another quite interesting compromise that allows you to maintain the mapping between the complex subgraphs and objects could be JSON LD documents and JSON LD frames. So it's yet another quite interesting concept that you could bring entire subgraph actually as a JSON LD frame that could be embedded to the complex object, and then you will have the triple that actually instantiate as a document that maybe developers will be happier to work with. So the object to graph mapping, it's not so straightforward topic, and it's also tightly related to the modeling. And usually we have two distinct processes in modeling, right? So we have our ontology building, and we have our ontology mapping to the object. And it's better to see these two processes separately, because then you will be more flexible on this. And when you try to solve both of them at the same time, then you could have a lot of challenges. So then maybe focus on the ontology first, and then think about your use cases and what kind of shapes of concrete subgraphs you have for the concrete use cases, and then you could go from super flexible ontologies to more fixed object aggregates that allows you to do your job more effectively. So just my ideas for now. If you have some thoughts around it, or you're working in a graph database together with the classical object-oriented applications, I keen to hear your feedback, and maybe you have a better way to solve these challenges. So that's all that I was keen to share with you today. And I will be out so for some period of time, because I attending the DICE conference, and if you're working in a self-sovereign domain and interested in credentials and sovereign data, I will be happy to talk with you at DICE in Zurich. If you're working more on the graph sides, I also will be happy to catch up with you if any. So give me a shout. Choose.